Okay, so Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imran, and today I'll be presenting about the Smart Adjustable Headrest for Cerebral Palsy using 3D printer. Okay, let's move on. Alright, so for this project, I'll be heading first to the content. So my first is the project summary, and the second is introduction, and third is methodology, and fourth is the preliminary outcome. I'll go on one by one. So first, let's make things clear. I will explain on the definition and terms. So first of all, the terms is CP, which is used for cerebral palsy, and then hypotonia, which is an abnormally low level of muscle tone, hypertonia, an abnormally high level of muscle tone, spasticity, which is stiff muscle, dyskinesia, which is uncontrollable movements, and ataxia, which is poor level and coordination. Just for the introduction, this is my project summary. So first of all, I want to bring a smart adjustable headrest for children with cerebral palsy. Okay, so what does it mean is that I will design the product to be used for the children. And then, of course, this device is targeted for individuals from the age of 7 years old to adult, with the emphasization for the children with cerebral palsy. It means that even if you are a normal person, you can still use it. Okay, so for the target is for GMFCS level 4 and 5. I will explain to it later. And then the device will ensure the improvement of user's posture, as it can be controlled by moving the headrest unit horizontally and vertically electronically. And of course, the design is created and modeled in SolidWorks 2018. It's also controlled by a microcontroller. So, introduction. So, why headrest? Headrest is a really important device as it will ensure a good posture for the user, as it will support their head. And then usually the design for the wheelchair and chairs in the market right now, there is usually a lack of proper headrest, and worse, it does not come with one. Like the one I am sitting right now, it does not come with a headrest. So, and then some of the cerebral palsy individuals' muscles are in the state of hypotonia, where they have zero control of their head movement, as they move randomly in any direction. And of course, if you have the current one, they usually are fixed or manually adjusted. Okay, so my problem statement. So firstly is the lack of availability of smart adjustable headrests in the market, and the current one only offers manual adjustability, like what I said earlier. And then the head freedom movement is restricted for cerebral palsy individuals, where they heavily rely on headrests to erect their head upright. So what does it mean is that the headrests will make sure their head stay upright, like what I'm doing right now. Okay, and then the lack of research and technology towards headrest technology. So my main objectives for this study is firstly to design a smart adjustable headrest for an individual with cerebral palsy. And then secondly, I want to fabricate the smart adjustable headrest using a 3D printer, and want to integrate it with IoT system, or we call it Internet of Things. And then of course, when there's a design, there will be a scope and limitation of it. Okay, so my scope and limitation. So firstly is I am focusing on the design of the smart adjustable for a cerebral palsy individuals, where the focus are the design and the mechanism of a headrest. So what does it mean is that the mechanism of the headrest are, let's say, the mechanism for moving it horizontally and vertically. I will focusing on the designation of that. Okay, so the device. Secondly, the device can be attached to any type of chair or wheelchair by using the specially designed clamp. So what does it mean is that the clamp can actually be put on top of maybe any type of chair. Maybe the choice is limitless. We'll see later. And then the main target is for GMFCS level 4 and 5. Of course, the device will be fabricated using 3D printers, and the materials will be used with PLA. And then I want to analyze the capability of the device. Static analysis will be performed. So let's move on to the literature review. Okay, so firstly, what is cerebral palsy? So we always heard about cerebral palsy, but do we know what is it? Alright, so on the picture of the left here, that is the person with cerebral palsy. So the definition of cerebral palsy is the condition where it affects the development of movement and posture, causing the limit in activity which contributed to the non-progressive disturbance that take place in the developing fetal or infant brain. So what does it mean? That it is a condition, it will affect their movement and their posture, which means they might not have any control over their movement and posture. And it takes place in the fetal or infant brain. So fetal is basically after the embryo process, it will become fetus. So it was in their mummy's stomach. Okay, and then secondly, it affects 2.0 to 2.5 per 1000 live birth. And then the motor disorder of CP are usually coming together with the disturbance of sensation, cognition, communication, perception, and or behavior, and or by a seizure disorder. Right. So on the left here is the damaged brain for the cerebral palsy babies, and then over right here is the fetus, or we call it as fetal. All right. And then to classify the cerebral palsy, there are two ways. So firstly is the classification based on the predominant motor disorder, and the second one is by the gross motor function system, or GMFCS, like what I was said earlier, GMFCS level 4 and 5. Right, so let's move on to the first one, the predominant motor types. Alright, so there are three predominant motor types, which is spastic, ataxic, and dyskinesia. So usually for spastic cerebral palsy, the probability of getting it is 65% to 98%. So this is all of this figure is based on the studies done by the studies done in the Victoria, where they compare the list of registry from several countries, and they compare it with their own records from the Victoria, which is in Australia. Alright, so second one is ataxic cerebral palsy, which occurs on 1 to 11%, and dyskinesia cerebral palsy, which is 2 to 15%. So I've already talked about the definition of spastic, ataxic, and dyskinesia early on. Alright, so let's move on to the next. Alright, so for GMFCS level 1, so we can see the children can walk at home, school, and outdoors, and etc. etc. Basically, they can do like a normal children, but it is tiny bit of limited, but they can still do it. Alright, so for GMFCS level 2, the children can walk, but they need to hold their hand onto the rail, and when walking long distance, they cannot do it. Okay, they may experience some troubleness when doing long distance. For the level 3, they can walk by using hand mobility, but during indoors. But when they are going outdoors, they cannot. They must rely on the wheelchair. And then for JEP level 4 and 5, which is the most chronic one, it is the most horrendous one they will ever experience. So level 4 and 5, basically they require mobility assistance. They require a wheelchair, and their headrest will hold their head. That is for level 5. Basically JEP level 4 and 5 is there's a thin line between them. Yeah, basically they both need assistance to do their day-to-day life. Right, so let's move on. Alright, so postural control. So when we are talking about postural control, is basically we control our posture, how we keep our body upright. So the definition of postural control is described as the capability of equilibrium maintenance and to ensure the center of mass, COM, is bound in the stability limits of the body. The involvement of resistance to gravitational force and mechanical system during movement. So to sum up, the children with cerebral palsy cannot control their body posture, and it shows when the children are sitting in a chair. They will be swayed substantially more in the lateral direction compared to the children with a normal condition. So what does it mean is that their head will move in the lateral direction, like over here, lateral direction. So it will move like this. So they must have something to hold their head. Alright. Okay, so let's move on. Alright, so and then we move on to the methodology, how I do it and why I do it. So this is the flowchart of the project. I will start with the discuss on the problem statement and objective, gather information, concept generation, concept evaluation and selection, preliminary design, IoT code writing, IoT assembly, detail design, FEA analysis, patient assembly, testing, all the function of prototype, and right. So and then for the phase 1, I've already established the PDS, or product design specification. So firstly, we will talk about, so this is the product design specification that I have to do it. And this is the one that I'll be referring to. Okay. So, Alright, so this is from the PDS. I've already established morphological chart from going through all the patterns about the mechanism and all. So this is what I have already established based on the conceptual design based on the PDS that I've established earlier. So as we can see, this is so there will be 4 concept drawing that came up from this morphological chart. Right, so this is the first concept, this is the second concept, this is the third concept, this is the fourth concept. So I will be choosing the third concept based on this per chart. And this one will be the datum, or will be the one that will be the benchmark one. Alright, so the third one is the heaviest around here, 15 points. So I will choose the concept. Alright, so and then we move on to the embodiment design. So the design will be modeled and run to static analysis through SolidWorks 2018. And the dimension used to model design is based on the anthropometry of individuals aged 7 years old and above. Electronic parts will be simulated assembled through the Tinkercad website. So this is an example of anthropometry of an adult woman. Okay. So fabrication and assembly. So of course after all of that, I will fabricate and assemble using 3D printer and using filament of 1.75mm diameter. The material is PLA or polylactic acid. Alright, so let's look at the preliminary outcome. So for as I said earlier, I've already designed it in SolidWorks 2018. Okay, so for this I will demonstrate how the functionality of it works. So as you can see, this part will be moving up and down vertically, and for this is the clamp. The clamp will open it. The clamp on the below will open it to make it easy to clamp onto the chair, onto the surface. And then the headrest unit can be moved horizontally, forward and backward to give the user more comfortability. Alright, so let's move on to the next one. Alright, so this is the exploded view for the headrest unit, as you can see over here. Okay, so I'll talk a little bit about the component that I'll be using. So this is as you can see, there are a worm motor, and then I'll be using a rack and pinion to move the headrest forward and backward, or horizontally in horizontal direction. So for the vertical direction, I'll also be using worm gear motor to provide higher torque. It has a lower speed, but it has a very high torque, which is what I want, and it has a self-locking mechanism. But what does it mean is that whenever the gear does not have any electrical on it, it cannot be twisted that easily. Okay, so yeah, and then for the mechanism, as you can see over there, I'm using the lead screw with mechanical coupling. Alright, so let's move on to the next one. So the Tinkercad demonstration. Alright, so let's try play. Oh, totally play. Okay, never mind. Alright, so for this, as you can see, there are four buttons. So there will be 2 buttons for every motors. So what does it mean is that for the horizontal motor, there will be the button controlling going forward and backward, and for the vertical motor, there will be another 2 buttons controlling it up and down, or we call it in vertical direction lah. Alright, so as you can see, they are moving as accordingly, and I also provided a multimeter just to see if they are working properly. Alright, so thank you for listening. So I'm sorry if this presentation is not perfect, but you can contact me if you have any inquiries. Feel free to contact me at imransufian@gmail.com or through my WhatsApp number at 01322222639. So assalamualaikum warahmatullahi wabarakatuh. Thank you for listening. Bye bye.